what you're seeing here is version 3 of the MeArm using a Microbit. What follows is a build along video with me, Ben Gray, the creator of the MeArm, and we are building a MeArm version 3. It is not a step-by-step build, but just a build along. So if you're following instructions at home and you're curious about how a part's put together, you should be able to see it here. I made this without the instructions, so this is just a raw build with me building to memory of how I would probably put it together.
Try and keep things tidy, the eye out of the way.
So I'm just cracking on here. I've opened up the screw bag, I've put the servos are pre-calibrated, and I'm just working out what needs to be done.
Here.
So
This here.
Placing the first servo motor into the PCB. You can see on the bottom of there the white markings on a PCB are called a silk screen. And here I've said I've calibrated the servos, but I've actually calibrated them slightly wrong, which means there's another video that I need to re-record. Now I need the two end pieces to slot over, and in fact what I need to do here is I need to wrap the cable through that first piece that I've put on. Well, I'm just going to go ahead because I've forgotten about how to build on these, because it's been a couple of weeks at least. So this piece that I'm doing now I'll undo shortly after and wrap that cable around the centre point. Cable management's all important, of course. First of all, it looks nice and neat, but second, if your cables are managed nicely and put in the right places on the MeArm, then you're not going to catch them when the arm is moving around. Again, so probably just getting a bit ahead of myself here by putting these sides on. But you can see this all sort of holds together fairly well as they slot through the PCB, and I think it's dawning on me now that actually I need to wrap that cable through the middle. I'm doing that off camera, which is really handy. But there are two holes on that middle acrylic piece, and you can just about see there I'm threading the cable through with some difficulty. I've not said any rude words yet, so really this video is going great. So once that cable's through one more time, we can plug that in, and the pin header is just right there next to that centerpiece. And on that pin header there is a small O or a dot, and that dot or O, the O is for orange, so the orange cable from the servo motor, which is the signal cable, goes to that piece. So the servo motors have three wires on them, a brown, a red and an orange. And the orange is the signal wire, the red is the voltage, so it's the main power line, and then the brown is the earth or negative. So now, very quickly, those bottom pieces have gone together, and I'm getting these pieces which are sort of hockey stick shaped, and they slide through the back pieces with a little bit of wiggling, and once they're through we'll use a screw to secure them. So I think on this I'm going to need to move that cable out of the way on that one, but just by putting one of them through holds it in place. So they slide through and hold everything down, and then they hook slightly over the back of the PCB. A PCB is a printed circuit board, so that's what that black piece is. Usually made from fiberglass with with copper to conduct the electricity through there. So we use it structurally on this as the base of the arm, but then also to carry the signals and the power to each of the servo motors. And that's what obviously you need to move the robot arm. Using the Allen key there, or hex key, L wrench, all different terms for that, and that comes in with the official MeArm kits, and those are hex-headed screws. So what I should say here is there are many versions of the MeArm out there, and so this one is version 3. This is the culmination of 10 years of work. and has many improvements in there, incremental. There are a couple of leaps in terms of when we did Kickstarters and things like that, where we had really intensive development periods. And if you bought a MeArm from elsewhere, you're probably seeing different parts, and you may well need a different video and a lot more time. This video I think is about 27 minutes, and that's with a bit of messing around in it. A straight build you could do in about 20, whereas say the MeArm version 0.4, which is very popular, and the MeArm version 1, both of those take about 2 hours for me to build, so it's a significant investment in time. So this piece here is a little trickier than I remembered, and I think I might say that just in a moment as I try to get this screw through. Waiting for me to speak.
It's a bit tricky.
So I left the audio in from the video recording. There you go. It's a bit tricky. So what we're trying to do here, when we screw in, so there are no nuts in a MeArm version, in a MeArm version 3. Whenever these machine screws go into the robot, they cut into the acrylic, and they sort of self tap. And this piece uses these sort of E-shaped pieces of acrylic to put in the middle of this sort of central strut, and we screw those in. Those can be screwed in quite tightly because we don't need any movement on that part. So on the MeArm there are parts where you just want to secure things together, and there are parts where the screw acts as a pivot. So you can see I'm just sort of testing that for there's a little bit of torsion there, so you can twist that part slightly, and we want to minimize that. I may be looking at this part again just to for future versions to minimize that torsion. So I think later on I go back and tighten those up a little bit more, but you always have to sort of be careful tightening up things on the arm, because you really don't want things to crack. Now we're adding the first pivot. So this is just using one of the 6mm screws. So in these kits there are 6mm and 10mm screws, and also some 20s. You see that 6mm's just gone into that central piece, and now we have the first pivot. And on all of the pivots, you want to tighten them enough so that there isn't any play in the joint, but also that the joint can move easily, because each of these joints is going to be moved by one of your servo motors, as I'm holding up here. And your servo motors don't want to have to work against a lot of force. So really you want your MeArm to sort of behave like a marionette, so that when there's no force applied, just so that it's very easy to move those pieces. So now these are some of the 10mm, 12mm screws. And these servo collars, you place the wire through them first and then thread them through. And then you place the 2 screws either side, and then what's called the servo horn, which is that black plastic piece on the end of the servo, that fits into like a registration slot on the joint, as you can see there. Finding that little googly eye in the middle of the shot slightly disconcerting right now. So yeah, so as I mentioned, so I'm now tightening these up a little bit more, just to reduce that twist, that little bit of sort of torsion. Now, while you can move the servo motors manually, it's not advised. So you really want to do that beforehand. So this is the next lever. So this is where the other servo sits in. So this is made from 2 pieces. So we use one of the 6mm screws through it, so it'll push through the first piece and then screw into the second. And then the piece on the end, you can push the screw straight through that, and that will screw into a lever, which goes. So it's not this lever. So this lever has a little triangle on it, and that's just to indicate it's different to the other. I think there's 3 that are the same and 1 that is not. Or maybe 2 that are the same ones, it's not. So these two are the same, so you could use either one of those without the triangle on. And you see, so it pushes through, and then it screws into that lever. And what I've done is I've lined that that lever up with the back of this piece, so they're completely overlaid. And that means when that screw self taps into there, it will go in straight. So again, so it'll minimise play, and allow you to move that piece easily. So now I'm going for the next piece of this lever. So this is a longer piece, and I'm about to screw this in incorrectly, so it doesn't go into this hole. So don't follow this step. Wait a couple of moments until I realise and screw it into the correct place. So it actually goes into the end of that to make a sort of a parallelogram lever for lifting the head up and down. So I've got it moving nicely. Am I about there? And I've given a little bit of extra tightening. Still in the wrong place, so don't do this. I think that little hand movement said I've realised what I've done wrong. Still managed to not say any rude words, so that's great, and keeps us in the PG category. PG because some of this requires a bit of hand strength and small parts. So I mean, really, you should be able to trust a child to do this on their own. But you want to stay focused. It might take a couple of seconds. It might take a couple of sessions to put together your MeArm. But again, so we're overlapping those pieces, so they're flat together as we screw in, and that self taps that screw. So that is now the correct mechanism. And just making sure, so I think that's untightening slightly, so there's a bit more movement in there. And this overlays, and if you can see there's a hole in that piece, and that goes onto the screw head that we previously put on there. So that's where these machine head screws come into their own, because we can actually use them as a pivot without screwing anything through them. So that piece just sits over, and when we put the servo on there, that pushes it on. So we're using another 6mm screw just to put that on, and that is the mechanism on that left side of the MeArm completed. So annoyingly, just watching the video through and saying left side, it looks very much like the right side, but this video was recorded backwards, so we may have to flip that sideways. So if you're watching this now, it should be correct. I'm just providing a narration as I go through, but I've realised that I flipped this horizontally because it was recorded from the other side of the desk. But actually, to be the correct orientation, to make the MeArm in the right way, we're actually going to have to flip it the other way as well. But I will have done that by the time that you watch this video. So this will be in the correct orientation. And what I will be putting on now is I will be putting in the servo on the left side of the MeArm. So if you hold your MeArm and it faces away from you, you'll be looking at the left side here. What this video has made me realise as well is if you look at some of my other videos, you can see I work in an office in the garden that I built with a couple of friends last year, and the aspect's lovely. So when the laser cutter's not running, you can hear the birds singing. So just outside there's a couple of big hedges and some tall trees, and birds found themselves a home there. There's also some squirrels around, so I'm very tempted to do some Mark Rober style videos, but that's for another day. If they turn up, brilliant. Now again on the cable management, so I'm just wrapping the cable around the servo. You can actually, if you do it very carefully, you can actually tuck that cable just underneath the screw on the top. And then I'm also again lining up the orange cable with the little O or the dot that's on that printed circuit board at the base. I'm also now realising I should do that on the other side and also plug that in. So once again, we're just wrapping that round and putting it tightly away. With a little bit of difficulty, of course, because when you film yourself doing things, they never quite go smoothly. See, on this one you can see I'm just tucking it into that little piece on the back of, we call them collars. So little piece on the back of the servo collar just allows you to tuck that cable away so it stays nice and neat and doesn't get caught up in the moving arm. We're about to assemble the last piece of the main arm, and this has that triangular piece you see there with a little triangle on it again, just to show that's together. There's a little spacer here that I've just taken out. Put those pieces away for later. And now these last three levers we'll put together. So on the piece furthest away on the triangle, so the piece that's sort of, if you were to sit it down and have the piece that's furthest away from him, and you can see the piece in my hand. So we're just securing that with a 6mm screw, and then the piece with the triangle on it handily goes on with the triangle look. So I've put them next to each other. So if you put those close to each other and put them on so they're on the same side as the piece you've just put on, screw that together with 6mm, that'll be good. So the difference in that part is that has a through hole and a screw hole on it. So the screw holes are slightly too small, so that, you see, we're tapping into that. But the other side of that piece has got a through hole in it, so that's what makes it different to the other levers. The other levers are identical and are both screw holes. So that has a screw hole and a through hole. So the through hole is for putting on the head of the MeArm. And then this final lever, you see it has like a circular piece on it, which again differentiates it. And the circular piece matches up with that central part. And there we go, we need to screw that onto there. I'm just showing you the spacer here. So this sets up the parallelogram on this side and holds it steady so that the motion of that right arm will just move it in plane. Now I'm going to put on the base. So we'll find those pieces, and this just slots through. And since I've been looking at this this week, that may change in future. So if you have a piece that looks very much like that, it's just got a hole in the middle, don't worry. You've got the slightly, you've just got the next version, which hasn't yet been built. So if you have got the version you're seeing, then that's also great. There's just not an issue. It doesn't catch in any major way, but just causes a bit of extra friction when that top plate rubs over that slot. So I just thought, actually, for one more step, we can remove that and just make the action a little bit smoother. Now we're going to put on the sticky feet. All good electronics projects need sticky feet. You can see that the two 6mm screws I've put through there protrude slightly, so if you don't put on the sticky feet, it won't sit flat on your desk. So by putting these on, it means that there's a bit of clearance, and yeah, you've got sticky feet to protect your desk. The last one was a bit tricky, I seem to remember. There's a bit of adhesive backing on them, and yeah, that one came off without it, so it just took me a couple more moments to put that together. But that's great. So we've built the majority of the MeArm. We just need to build the head now. So I've put that across to one side, and that remaining servo, we're going to use that. And I think I have a couple of full starts on this as well. So I'm just getting together all of the pieces that we'll need. So you can see there are 3 pieces of a similar shape, and then there's the actual cool bits, the claws, and then there's a couple of funny shaped bits which sit in between to get your ratios right. And I think I actually build this backwards to start with. So actually you're getting two builds for the price of one. You're getting left-handed and right-handed, and you want to do the second version of this. So we can watch how we put it together, because the principle is exactly the same, just the other way round. And that sounds like my printer spooling up helpfully in the background for no reason whatsoever. So yep, so these push into some holes on there that match them, and then the next piece that goes over the top, so move that manually. Again, you can move these Metal Gear servos, will put up with being moved manually most of the time. Sometimes they're a bit sticky, and in that case just go easy, especially if you've got them on the robot arm, because sometimes they'll give and you could snap some of the acrylic. So go easy or move them electronically. It's the advice I give. So now we use the two 20mm screws, and they just go straight in through the top. And if I put one in now, I can screw that in and that will hold together. See, it's just wiggling around at the bottom while it finds its registration hole. So even though I'm putting this together the wrong way, and I may well be realising that now. Yeah, I think I've just realised. So, so here we start again. So you can push that back out. So that's a through hole. Take that out and put it in the other side. Yeah, so here we go. So that was the practice run, and this one's for real. And yeah, so we're just doing that process again. It's always good to see something twice. And push that one through. And then this goes on. Yeah, I think we saw it last time. So place it on over the top, and then it spins right the way around, so it's in the right way. So those rectangular pieces on the back, I don't know if this is going to be easy to explain actually, but they give you the right width. So acrylic is a bit of a funny material in that you'd think it would be a much tighter tolerance than it is, but 3mm acrylic, which I don't know what that is in imperial measurements, or US, as people in the US like to call it, but it varies massively. It varies by about plus or minus 20%. So when you're building something like this, you have to take that into account. So any piece that you can cut accurately, and any piece that you rely on the tolerance of, try not to rely on the tolerance. So now this piece again, so I've just put the claws on there. You can see it goes straight into the registration of the servo horn. The gears mesh together, and I think this took a little while for me to line up. So actually what I needed to do, and what I do eventually, is the plate that so this pushes through the two through holes. It takes a little bit of doing. And then the screw hole at the bottom was slightly misaligned. So that just needed a bit of a wiggle. So that takes me a couple of moments, I think, and I think so I attempt to put this on, don't quite get it through, but actually to line it up, you'll see what I do in a minute as I sort of take it back apart and make sure that everything's lined up. Sometimes just pushing and turning it around doesn't work, so that's a piece of advice that's probably made this video worth watching. So really you want to align these pieces, and you could see that more easily when you first put the claw pieces on, but I'll take it apart in a minute, and you'll hopefully be able to see that. So I'm looking here and thinking, no, that doesn't quite line up. Why doesn't that line up? Is this cut badly? But no, it's not cut badly. So just in the tolerance of the acrylic, sometimes the alignment takes a little bit of nudging, and that's what I'm about to do. So we can just take that off that bottom hole. That through hole is a little bit tight, but I think I kept that quite tight. And in fact, I think what I'm doing here as well, just opening it up ever so slightly with the back of the L wrench, and then just starting the thread as well. So so as they're self-tapping, just giving a little, if anything's tricky to tap, tricky to turn, you can just start it off. So you start the thread, so rather than going straight into self-tapping, you're actually going into the start of a thread, and then it'll cut through much more easily. So I think that's gone through more easily. It's lined up, and now it's actually starting to cut through. So you'll, oh, that actually cut off. So but as you can see, that worked out okay. So this is one of the first videos we've shot, so I'm still getting used to some of the setup, and I think the camera that I've recorded this on, the SD card wasn't quite up to the job, so every now and then you get a bit of an overrun on the buffer, and the camera just turns off. No audible beep, so you just have to watch out for it on the camera. So I think this video took about four attempts to get it all, and yeah, that buffer overflow stopped us. So what I'm doing here is I'm putting the head onto the arm. So this is kind of the final step, really. So this just uses uses those 6mm screws again, and it goes through the through holes on the levers, and just screws into those side pieces that we use to build the head. And again, here you're just trying to minimize play, and this is an important cable to put through. So there's a few little holes for cable management. One on the servo itself, one on on the head assembly itself, and then a couple on that central strut. So this cable is just long enough. So we used to have an extender cable, but by using the PCB on the base allows us to not have to bother with an extension cable. And there you go, that's it, built. And yeah, so now you attach your controller, that's me giving a thumbs up, and you're ready to play. Oh, one last step. That googly eye that's been looking at us the whole time. So your kit should come with one or more googly eyes, and you place them as and when you wish. If you're really lucky, I mean really lucky, because there are, I think in the packs that I buy, they've got something like 1200 googly eyes in. I think there are about 4 of these fellas. So yeah, if you're really lucky, you get one of these massive ones, and they're my favourites at the moment. And there you go, your MeArm is built, and you can plug it in using your favourite controller or one of our control boards, and you're ready to play. So thanks very much for watching. If you've liked this video, check out the rest of our videos. I've been filming some daily diaries and also more instructions videos. So if you need to build a controller, check out our other videos that should be appearing on the screen right now. Don't forget to like and subscribe. Thanks for your time. Bye bye.